Hello, this is MATH1231, Maths 1B, and I'm having a look at a sample test for Test 1 for calculus. So this is an old sample test, an old test from 2009. You'll find these located in the back of the calculus notes and exercises. There's a number of these tests there. I'm just going to do one of these just as a sample test. You use these tests in your own way, but one suggested way of doing it is to watch the video firstly without taking notes, and then go back through the test and see if you can write out the solutions yourself without looking back over the solutions I've given you. That might be a very useful way of learning the mathematics. And also make sure that you're setting the material out properly. And I'll try and give you a reasonable model for doing that. Okay, the first one says we're given a function z of two variables, it's x times y, and we're given that x is 2 cos 3t and y is 4 sin 3t, and we're asked for the derivative of z with respect to t. Now, of course, one could cheat very easily with this, and that is you just multiply these two together and you get 8 cos 3t sin 3t, and then you just differentiate using high school methods. However, the question specifically says use a chain rule to calculate this. So what they're making you practice the chain rule. So if you did it the high school way, you probably wouldn't get any marks. So you'll have to do it by the chain rule. So the chain rule is very simple here. You just look at the way the variables are connected together. If I asked you to calculate z, you would need to know, firstly, the value of the variable t. Using t, you can get x and y. Using x and y, you can get z. In other words, z depends on x and it depends on y, and each of these depend on the variable t. So I like to draw up a little chain diagram here like this that tells me how the variables are related. So if I want dz dt, z ultimately depends only on t, so dz dt, using the diagram, that's how I remember the chain rule. So I go from z to x, and so that's partial dz, partial dx. Notice, be very careful with your total derivatives and your partial derivatives, because z is a function ultimately only of t, so it's a total derivative, but it's on the way, it's a function of two variables, and so I use the partial derivative. Multiplied by the derivative of x with respect to t, and so I use a d here because that's a total derivative. Plus, I could have gone this way in my little picture. It's just a mnemonic, a way of remembering the chain rule, and so that's partial dz dy times total dy dt. And now I just have to substitute, plug in the values. So dz dx takes the value y, dx dt I differentiate from here, I get minus, bring out the 3, I get minus 6 sine 3t, and then plus partial dz dy gives me x, and partial dy dt, that gives me 12 cos t. And I suppose I could technically leave it like that. I might tidy up with this minus here a little bit. So that's minus 6y sine 3t plus 12x cos t. If you wanted to, you could replace the x and the y now by these and simplify. That's okay, but we were just asked for the derivative, and it didn't say in what form, and so I have calculated that using the chain rule. Quick correction to the answer. I noticed in looking back at the video, the last line I'd left out the 3t there, so please note that it was minus 6y sine 3t plus 12x cos 3t. I'm sure you picked up the error, but there it is, and now we'll go on to question 2. The second one gives us a surface, and we're asked to find a vector normal to this surface at this point. I've called it P. There was no P in the question, but I always like to give a point a name so I can set it out neatly. So there's my surface and there's my point, and we want to find the normal vector to the surface and also the equation of the tangent plane. So those two things. So imagine we've got this surface here, We've got some sort of surface. We've got our point P on this surface. There's the point P, and we're looking for a vector that is perpendicular to the tangent plane at that particular point. So imagine taking a surface, put a piece of cardboard on the surface at that point, and take your normal coming up there. Now there are various different ways of doing this. I like to do all of these in the following way, which is a method that works in every situation. I will get all the terms onto one side, and I call that function f, capital F. So I get 3x squared minus y squared minus 2 minus z, and this is going to equal then 0. And I calculate then what we call grad f, and grad f is a vector consisting of all the partial derivatives of this. So partial derivative with respect to x is 6x, with respect to y is minus 2y, with respect to z is minus 1. So I calculate this thing called grad of f, and because this vector gives me the perpendicular to the surface at any point. That's a lovely fact. This gradient gives me a vector that sticks up from the surface at any point I like on the surface. When I substitute it in, it gives me a vector sticking up from that point. Now we want to know what it is at the point P. So I'm just going to substitute in x is minus 1, y is 2, and z, well, z just stays at minus 1. And don't forget to write the English at P, because that doesn't equal that, it only equals it at P. So that is my normal vector. That is the normal vector they wanted, minus 6, minus 4, minus 1. Now, to get the equation of the tangent plane, again, there are many different ways of doing this. I like to just think of it like this. You saw in Maths 1A that the equation, for the equation of a plane, the coefficients of the x, y, z are just the normal. So in other words, this plane has equation ax plus by plus cz, where the a, b and c are just these components, equals some number d. So I'm just going to write down, without doing too much work, the equation of the tangent plane is minus 6x minus 4y minus z equals, now we don't know quite what this d is at the moment, I'll just put a d there for the moment. Now we do know it's got to pass through P. So I can now go back and say, look, we know this passes through P, so I can substitute that point in, and that will give me the right-hand side of the equation. As I mentioned, there are other ways of doing this. Your tutors may have shown you other ways as well. So I will just substitute in the point P, and so I get 6, I get minus 8, and I get minus z. Well, that's plus 3 is equal to d, and so I can simplify this and just get 1. So finally then, the equation then is, I don't like all these minuses here, so I might just tidy up a little bit and multiply both sides by minus 1, just to make it look a little bit more attractive, and I get, there's the equation of the tangent plane. So remember, all you need to do, you calculate this grad vector, this gives you the normal anywhere, work it out at P, there's your normal vector, and the normal vector gives you the coefficients of the x, y and z in the tangent plane. And so I substitute it in, and I just get 1 from the other side. Now, for the question 3, I'm going to do an integral. This is the integral of sec to the 4th theta d theta. So an integral sec to the 4th theta d theta. So again, I'll just make some space for myself here. Now, when you're doing these integrals, you really need to make sure you've practiced your basic integrals pretty well, and you need a little bit of insight in doing these. There's no universal method for doing these, so I'll try and tell you what's going on in my head when I look at an integral like this one. So the first thing I can see is sec to the 4th, and I think, well, what formulae do I know about sec theta? Well, I know 1 plus tan squared is sec squared. So let me just write over the side here, 1 plus tan squared equals sec squared theta. That's one of the Pythagorean identities I hope you learnt back at school. And that gives me the hint, it gives me the insight to split this up into a product of two secs. So I get sec squared theta multiplied by sec squared theta. That is why I'm doing it. I'm keeping this identity in my head. And now I'm going to replace one of these with this thing and see what happens. So I get the integral of 1 plus tan squared theta multiplied by sec squared theta d theta. Fine, might multiply it all out now, so I get sec squared plus tan squared times sec squared theta d theta. Now you stare at that for a little bit and you say, well, do I know the integral of sec squared? Yes, we know the derivative of tan is sec squared, so going backwards, the integral of sec squared is going to be tan theta. Just check, tan goes to sec squared. Now for this one, you can make heavy weather of it and you can put substitutions, you can put u equals tan theta and spend another 5 lines doing it all out. I just, at this stage of your mathematics, you should just think of it like this. This is really, this tan squared is just tan of theta all squared. And so you're thinking of the chain rule backwards. The derivative of tan is sec squared. So the derivative of this inner term is sitting there waiting for you. And so I can just do this by just normal rules of increase the power by 1 divided by new power because the derivative is sitting there. That's the only reason you can do this. So I'm just going to write down tan cubed over 3. Now let me just check that is correct. So what do you do going backwards? You bring the 3 down the front, cancels, you get tan squared, yep. You multiply by the derivative of tan, sec squared, and there it is. And so that's it, and then don't forget your plus c on the end. As I say, you can make it more complicated, you can put substitutions in here and do all sorts of things. It's only worth 2 marks after all. 1 mark for having the insight to do this, and then 1 mark for finishing it off. So that should be fairly short. Question 4, it asks us to use a trig substitution to work out the integral 0 to 2 square root 4 minus x squared. Now the question is very carefully worded because it actually says use a trig substitution. That is not just to give you a hint, it's also to force you to go down a certain path here. Because if I was just given this integral as it is, if I was just given this integral with no instructions on how to work it out, then I use nothing more than Year 7 mathematics, in fact, well, plus a little bit of some pictures, because if you think about this graphically, this is asking you for, if you put y equals to that, and square both sides, you get x squared plus y squared is 4, which you know is a circle of radius 2. And so taking the square root gives you the top half of the circle of radius 2, and integrating it from 0 to 2 just gives you that area. Well, that's easy to work out because the area of the full circle will be pi times r squared, and I want 1/4 of that. So there's the answer, pi. Without doing any calculus whatsoever, just using nothing more than Year 7 maths really, working out the area of quarter of a circle. However, the question was very cunning and it said do this by using a trig substitution, which I'll do. But of course this means it tells me I know what the answer is going to be at the end. I'm expecting to get pi out, so we hope that's what comes out at the end. So doing the substitution here, I would put, this is a substitution of the form a squared minus x squared, and so you've seen that little table in the booklet that you try something like 2 sine theta. Try something like x is 2 sine theta. Because then I could exploit that identity, 1 minus sine squared is cos squared. So I'm going to work out the derivative, so dx d theta is 2 cos theta. And then I'll give this a name, I'll call this I, and we're going to substitute it in. Well, firstly, by the way, when x is 2, we get theta equals, and when x is 0, I get theta equals. Well, when x is 0, 2 sine theta is 0, theta 0. When x is 2, sine theta is 1, so I'll take that to be pi on 2. So I plug all that information in, and I get the integral from 0 to pi on 2. Now I get the square root of 4 into 1 minus sine squared theta, factor the 4 out, and the dx I replace with 2 cos theta d theta. Now a little bit of simplifying here, I will get a 2 when I take it out of the square root, another 2 gives me 4, I might take that right out of the integral. 1 minus sine squared is cos squared, square root is cos, by another cos gives me cos squared theta. Now this is an integral that you should know and love from high school. It's in your Extension 1 Maths course. When you're dealing with these integrals of cos squared and sine squared, you have to use your double angle formulae. So this becomes the integral 0 to pi on 2. You get 1 plus cos 2 theta d theta, and you've got to divide by 2, so that'll come down to 2. And finally, when you integrate this, you get 2 into theta plus sine 2 theta on 2 from 0 to pi on 2. And finally, I can just squeeze it in here. When you put in pi on 2 there, you get pi on 2 times that's pi. When you put in pi on 2 in there, the sine of pi is 0 and the sine of 0 is 0, so that bit all gives you 0, and there's the value of the integral. And notice, of course, that had to agree back at what we got by using just elementary methods. And so there is the solution of the class test.